small ring P is threaded on a fixed smooth horizontal rod AB. Three horizontal forces of magnitudes 4.5 Newton, 7.5 Newton, and F Newton act on P. Given that these three forces are in equilibrium, find the values of F and theta. So before we do this, we need to resolve these three forces. So this, since it's acting in this direction, we'll have F sine theta, F cos theta. This will become 4.5 cos 20, and this will become 4.5 sine 20 in this direction. And for 7.5, it will also move leftwards, which is 7.5 cos 20, and this, and the component of the 7.5 Newton force, which is acting downwards, will be 7.5 sine 60. Sorry, this is 60. So let's read the question, the important parts of the question. So since it is a smooth rod, so there is no friction at all. And the other important key information that they've given us is that the three forces are in equilibrium. So and you might ask that why aren't we resolving the weight of the ring? The question states that it is a small ring. So that means that its weight is so small that it would not affect the state of equilibrium. So when we're talking about equilibrium, we know that the forces acting rightwards must equal to the forces acting leftwards. So first let's write this down. So that means that F cos theta is equals to 4.5 cos 20 plus 7.5 cos 60. And then we also know that there must also be equilibrium vertically, which means that forces acting upwards must equal to the forces acting downwards. That means that F sine theta plus 4.5 sine 20 is equals to 7.5 sine 60. Now, the two missing variables are F and theta, which means that we will need to use simultaneous equations. Now, one foolproof way that I always use and I have used in my exams is to make both of the equations in terms of cos theta. One equation needs to be in the form of cos theta and one equation needs to be in the form of sine theta. So this equation is already equal to F cos theta, so we need to make this equal to F sine theta. So F sine theta is equals to 7.5 sine 60, and then we'll take this on the other side, minus 4.5 sine 20. Now we can apply the rules of trigonometry. So we all know that sine theta divided by cos theta is equal to tan theta. So if we write F sine theta over F cos theta, the F's in the numerator and denominator will cancel out, and sine theta divided by cos theta is equals to tan theta. And we can express F cos theta and F sine theta as numerical values. So let's calculate this first. So F cos theta is equals to 4.5 cos 20 plus 7.5 cos 60, which is equals to 7.98. Let's round it off. And then so F sine theta is this, so let's calculate this. So it will be 7.5 sine 60 minus 4.5 sine 20, which is 4.96. So sine theta over cos, so tan theta will equal to sine theta 4.96 over 7.98. And then we can apply inverse tan. So theta is 31.8 degrees. Now we can use this value of theta and substitute it in any of these two equations. I'll just choose this one. So f cos theta is equals to 7.98 as we calculated over here. So that means that f cos 31.8 is equals to 7.98. So we divided both sides by 31.8. We know that f is equals to 7.98 divided by 31.8, which is, it's divided by cos 31.8, my bad. So 7.98 divided by cos 31.9, which is 9.39. So we can write it as 9.4 newtons. Then we can write and present our answers in the end. So theta is equals to 31.8 degrees and f is equals to 9.4 newtons. Part 2. It is given instead that the values of f and theta are 9.5 and 30 respectively, and the acceleration of the ring is 1.5 meter per second. Find the mass of the ring. So this means, so they've given us the acceleration, which is 1.5. So that means that this ring is moving this way. See? So we can use the forces formula, which is forward force minus resistive force is equals to ma. So that means the forward forces will be the forces that is moving them rightwards, and the resistive forces will be those forces which is moving it leftwards. So that will mean that f cos theta minus 4.5 cos 20 minus 7.5 cos 60 is equals to the mass multiplied by the acceleration they have given. So we can write this as f cos theta minus 4.5 cos 20 minus 7.5 cos 60 is equals to the mass, which we have to find, times 1.5, which is the acceleration. So, and they've given us the value of f and theta, so we can write it like 9.5 cos 30. So 9.5 cos 30 minus 4.5 cos 20 minus 7.5 cos 60 is 0.249 is equals to 1.5 m. So the mass must be equal to 0.249 divided by 1.5, which is 0.166. So we can write the mass of the ring is equal to 0.166 kg. Question number 6. A particle of mass 0.4 kg is released from rest at a height of 1.8 meters above the surface of the water in a tank. There is no instantaneous change of speed when the particle enters the water. The water exerts an upward force of 5.6 newtons on the particle when it is in the water. Find the velocity of the particle at the instant when it reaches the surface of the water. So first we should make a diagram to represent the situation, because we have a lot of information. So the first thing is mass is equals to 0.4, and since it is released from rest, it means that initial velocity is 0. And so let's assume this is 1.8 meters, and the particle will obviously be released from this point, and this is the tank of water, and there's an upward force of 5.6 newton on the particle. So basically what they're saying is that this is the resistive force that is acting in the water, which will prevent the particle from moving downwards. So this is 5.6 Newton. This is the resistive force. So part 1 just asks us that find the velocity of the particle at the instant when it reaches the surface of the water. So initial velocity is 0. We need the final velocity, and since it is still above the surface of water, the force of gravity is acting with it. So the acceleration will be positive 10, and there is this 1.8 meters needs to be covered. So the distance traveled needs to be 1.8 meters. Kinematics usually uses 3 formulas. One is V is equals to U plus AT. Second is V square minus U square is equals to AX. And the third is X is equals to UT plus half AT square. Now seeing the information that we have over here, the second formula is the most efficient way to solve it. So when we add this information, this will become, so we can find out the final velocity. See, pretty easy. This was pretty straightforward. So V square is 36, so the final speed will become 6. Part B, find the time that it takes from the instant when the particle enters the water until it comes to instantaneous rest in the water. You may assume that the tank is deep enough so that the particle does not reach the bottom of the tank. So they're saying that the particle comes to instantaneous rest in the water, so we know that the final velocity is 0. And so in the first part we found out the speed of the particle when it reaches the surface of the water. So, and they've also given us another key information, which is that there is no instantaneous change of speed when the particle enters the water. What the examiner is trying to tell you is that the speed at which the particle is operating at this point will be the same speed that it will have when it hits the surface of the water. So that means that this speed is the initial speed in this question. Now we can also use these formulas again in this part. So in this we have to find out the time. So the time is the missing variable. So we can use this formula if we have acceleration, which is V is equals to U plus AT. And so we can find out acceleration using the forces formula, which is that forward force minus resistive force is equals to the mass multiplied by the acceleration. So the forward force will obviously be the particle's weight. So that will be 0.4 times 10. 4 minus, and since the question has mentioned that the resistive force is 5.6 newtons, so this will be 5 minus 5.6 is equals to the mass of the particle multiplied by the acceleration. So, and then we divide this by 0.4. So the acceleration is minus 4, which is true and logical, since as the particle will be moving down in the water, the speed of it will slow down. So now we can use this formula. The final speed, since it comes to instantaneous rest, is 0, and the initial speed was 6. So 6 is equals to 4t. So t will be 6 divided by 4, which is 1.5. And you can write this down at the end as it takes 1.5 seconds for the particle to reach instantaneous rest. Now, this question was pretty straightforward, but usually sometimes the examiner will try to trick you by adding more, by changing the wording of the question. Now, in this question, they said to find the time that it takes from the instant when the particle enters the water. So sometimes they can trick you by asking you to find the total time until the particle reaches instantaneous rest. If they had asked for the total time from projection, which means from the time that it was released till the point that it comes to instantaneous rest in the water, you would have also found out the time that it takes for it to start from this point and reach this point, and then you would have added 1.5. So for part 3, you need to make a velocity time graph for the particle from the instant at which it is released until it comes to instantaneous rest in the water. So for this, you will need to analyze information given to you and also the information that you have gathered. And in order to make a graph, you will need 3 points. One will need to be the starting point of the journey. The third point needs to be the velocity and time at the end of the journey, and then you also need a point in the middle of the journey. This is because the journey from the instant at which it is released until it comes to instantaneous rest is in 2 parts. So since this is evident to you since there are 2 different accelerations. We all know that the gradient of lines in a velocity time graph is acceleration. So we found out that when so this is the particle, this is the 1.8 meters from which it was released, and this is a tank of water. So we found out that since it's still in the air, the acceleration was 10. So that means from this point till it reaches the surface of the water, there will be one upward sloping straight line. But then we also found out that in the first part that the final velocity over here at this point was 6. And then we know that from this point until it comes to rest in the water, which means final velocity is 0, the acceleration from this point to this point was -4. That means there will be another downward sloping line. So let's find out the coordinates. So since it was released from rest, we know that when time is 0, velocity is also 0. In part 1 of this question, we found out that the final velocity of the particle is 6 when it reaches the surface of the water. So we need to find out the total time it took from this point until the particle reaches the surface of the water. So we have the initial velocity, which is 0, the final velocity, which is 6, and the acceleration, which is 10 due to gravity. So we can use this formula, v is equals to u plus at, and you plug in the information. So it takes 0.6 seconds. So since it is continuous movement, the journey of the particle is a continuous movement. So that means that the total time will be taken, which is 1.5 plus 0.6, which is 2.1, and the final velocity was 0. So now we have 3 pairs. So now we have 3 coordinates and pairs of velocity and time, which is 0 and 0, 0.6 and 6, and 2.1 and 0. We can now graph this. We need to get a scale and measure. So I am taking 2 units on this axis, and then I'm taking 3 units. So label your graph. So the x-axis will be time and the y-axis will be velocity. So when t is equals to 0, velocity is 0. You can mark your points. So we have time over here. So we can use increments of 0.7. So that means this will be 0.7, this will be 1.4, and then this will be 2.1. Let's extend this a little bit to make it more neat. And so at 0.6 we have velocity is 6. So 0.6 will be about here, close to 0.7. So we can make 1 inch over here, 3, and this becomes 6. So at 0.6 the velocity is 6, and then at 2.1 velocity is 0 again. Now we can join these 3 points. These are two straight line segments. This point to this point is from release till the surface of the water, and this is from the surface of the water till it comes to rest in the tank of water. On to question number 7. A particle moves in a straight line starting from rest at O and comes to instantaneous rest at P. The velocity of the particle at time t seconds after leaving O is v meters per second, where v is equals to 0.6 t squared minus 0.12 t cube. Showed that the distance OP is 6.25 meters. So first let's draw a diagram showing the situation. So the starting point is point O, and then it comes to instantaneous rest at point P. So our initial velocity is 0 and our final velocity is also 0. And they're telling us to find us this distance. In this case, distance is equal to displacement. So they've given us the equation for velocity. First, we need to find out the time at which velocity is 0. So for that, we will equate velocity to 0. So 0 is equals to 0.6 t square minus 0.12 t cube. So first, let's make these whole numbers. So I'll multiply it by this whole, both sides by 100. So 0 is equals to 60 t square minus 12 t cube. Now we can simplify this further by dividing both these numbers, both sides by 12, sorry. So this will become 5t square minus t cube. So we'll take t outside, so this will mean that 5t minus t square is equals to 0, which means t is equals to 0, or 5t minus t square is 0. So let's solve this further. 5 minus t is equals to 0, so t is equals to 5. T is equals to 5 or t is equals to 0. This corroborates with the question, since velocity is also equal to 0 when starting from point O. So when time is 0, velocity is 0. So this is true. And at another point, when 5 seconds have passed, velocity is equals to 0 again. So this means that the particle reaches point P after 5 seconds. Now, in order to find the distance, we need to find out the displacement of the particle after 5 seconds. So we know that displacement is we can find the equation for displacement when we integrate velocity. And the limits will be 5 and 0. Since we need the displacement for 5 seconds, for the first 5 seconds. So this will be and when we integrate this, we'll have 0.6 t cube divided by 3 minus 0.12 t raised to power 4 divided by 4. So this will become 0.2 t cube minus 0.03 raised to power 4. And now when we plug in the values of 5 and 0, we will come with 6.25. I've only plugged in the value of 5 since we know that whenever we'll plug in 0, the answer will just become 0. So when we plug in 5, we get 6.25. And so we have proved that the distance OP is 6.25 meters. So we will just give a final statement at the end of the question. The distance OP is equals to 6.25 meters, and then in the bracket we'll write shown. Part B. On another occasion, the particle also moves in the same straight line. On this occasion, the displacement of the particle at time t seconds after leaving O is s meters, where s is equals to this equation. It is given that the particle passes point P with velocity 1.25 at time t is equals to 5. Find the values of the constants K and C. So when you will go through the other past papers, you will learn that there is a pattern. Whenever you have two missing constants, you will always be asked to make two simultaneous equations. For that, you will need to carefully look at all the parts of the question and also the additional information that are given to you. Now, in this part, they have given us that when t is equals to 5, your velocity is equals to 1.25. And then from the previous part, we also now know that the distance OP is equals to 6.25, which means the displacement of P when time is equals to 5 is 6.25. So since we have the equation of displacement given to us, first we'll solve that. So displacement must be 6.25 and t is equals to 5. Now let's simplify this. So 6.25 is equals to 125k plus 3125c. And then in this part, we know that t is equal to 5 and velocity is 1.25. And we all know that when we differentiate displacement, we get velocity. So when we differentiate this, we will get 3k t square plus 5c t raised to power 4. Since k and c are constants, we will multiply it. This will not go away. The constants will not go away. So in place of velocity, we will add 1.25, and then for time we will add 5. So 1.25 is equals to 3 times 5 raised to power 2, 75k plus, so we have 5, another 5 here, so this will become 5 raised to power 5 plus 3125c. So this is one equation and this is the other equation. you can see that 3125 and 3125c is present in both equations. So we can use any one equation and make it in terms of k and this value, or so basically we can write this as 6.25 minus 125k is equals to 3125c. And now we can substitute this value in place of 3125c. So this will become 1.25 is equals to 75k plus 6.25 minus 125k. So 75 minus 1.25 minus 125 is minus 50k, and 6.25 will go to the other side and get subtracted, so it's 1.25 minus 6.25, so this is minus 5. We divide by minus 50 on both sides and we get k is equals to 5 over 50 or 1 over 10, so this will become 0.1. Now we can substitute this value of k back in this equation and we can find out the value of the constant c. So 6.25 minus 125 times 0.1 is equals to 3125c. So c is equals to 6.25 minus 125 times 0.1, and then you need to divide it by 3125, so it's 0.002. Yes. So we write the final statement, hence k is equals to 0.1 and c is equal to 0.002. Now, part 3. Find the acceleration of the particle at time t is equals to 5. So we all know that when we differentiate velocity we get acceleration. So we found out the equation for velocity over here. So now we have the values of k and c, so we will need to plug in those values to find out the equation of acceleration. So acceleration is equals to 3 times 0.1 t square plus 5 times 0.002 t raised to power 4. Sorry, this is velocity, my bad. So this will become 0.3 t square plus minus 0.01 t4. So when we differentiate this, acceleration will become 0.6 t minus 0.04 t cube, and we will add 5, substitute 5 in place of t, and we will get 0.6 times 5 minus 0.04 5 cube minus 2. So we can write this as acceleration is equals to minus 2 when t is equals to 5. That is the end of question number 7 and this paper.